I think one of the key areas of support we got from NASA during the program was from the COTS assistance team, in which they really brought with them the detailed understanding of how the space station worked, how the interfaces needed to be managed between our spacecraft and the ISS, and how we could overcome the challenges they knew we were going to face in developing the spacecraft. Key areas like rendezvous and proximity operations, or in the communications area, areas where the interfaces are absolutely critical. The COTS and systems team was part of the program, adding in expertise, adding in technical knowledge where we needed it. They still allowed us to design the system we needed to design around our platform with our architecture, but they helped us understand the nuances of how that interface with the space station would work and how we could modify either the hardware complement or, actually in our case, more importantly, the software side to ensure that that interface would work. And then as we went through the integration and test process, they were part of the team that developed the interface testing that we originally did as part of the COTS program and we continue to do as part of the CRS program, so that we were testing our software and testing our hardware in the proper way. So it was very valuable. Oftentimes, in the interface to which you're attaching, in our case, it's the International Space Station. And so those interfaces are absolutely critical. And three areas where we interface: one is mechanical, which is the berthing mechanism. That's a system that touches the space station, the only part of the Cygnus spacecraft that touches the space station. We had issues there in terms of how to deal with contamination on the berthing mechanism before it actually touches the space station to make sure we don't damage it. There are interface issues with RF. We do talk to the ISS directly as we're approaching. We get telemetry back and forth between the ISS and the Cygnus. The crew members have the ability to abort the mission directly from the ISS, and so that interface is critical. And then software, that's a major interface because not only are there software interfaces between Cygnus and the space station, but the software is what's going to control how the Cygnus is going to operate and just how safely it's going to operate on its approach to the space station. In all of those areas, that is prime examples of where technical expertise at NASA came to bear to help us work through those interface issues. On the mechanical side with the CBM, the berthing mechanism, how we can ensure that it was contamination-free. On the software side, is our software adequately tested? Is it tested on a high enough fidelity platform? When we test it at NASA during stage testing, is the platform and the interfaces sufficiently defined so that the test is sufficiently flight-like? On the RF system, are the interfaces defined such that we know that we'll have reliable, safe communication between the ISS and the Cygnus at all time? In all those areas, there were resources that NASA was able to bring to bear as part of the development process and as part of the test and verification process that were extremely valuable in making that work. And I think in future Space Act agreements, any of those interfaces, I almost feel there should just be a picture with a line, and you define every interface, and each of those interfaces, someone should be assigned as the lead on each side. And I think if you do that, you go a long way to making sure those interfaces work.